Sir, please start.
Okay. Good afternoon, everybody. We are about to start our national webinar on awareness about green chemistry and nanotechnology. I welcome everyone present here, including our research persons, Professor Sanjay Bhar, Professor of Department of Chemistry, Jadavpur University, and Dr. Anirban Dandapat, Assistant Professor, Kumaun University, Uttarakhand. I also welcome all the participants present here, professor, assistant professor, associate professor, and of different colleges and universities, and our beloved student and research scholar from different college and university. I also welcome Dr. Sujata Bagji Banerjee, Principal KN College, Dr. Barnali Mukherjee, Coordinator IQAC, and Sri Biplab Bandyopadhyay, TCS KN College, and all other present here. I want to give thanks to Professor Sanjay Bhar and Dr. Anirban Dandapat for accepting our request to act as a research person to deliver a lecture on to current topic, green chemistry and nanotechnology. All were aware about the pandemic situation going on due to COVID-19 coronavirus, and we are all far away from our working place, our institution, college, university, etc. Classroom teaching remain almost closed. Teaching process continues by online basis. In this situation, we organize a webinar so that we and our students get to some knowledge about the situation. Further, another reference that in CBCS curriculum in chemistry honors course, green chemistry was included as a discipline-specific elective BSc paper on 5th semester syllabus, Kolkata University syllabus. From this webinar, our student may learn about green chemistry and enriched. Further, alarming situation coming due to non-green as usual conventional process of chemical transformation. We are using chemical products in our daily life, which are made by chemical industry. Environmental issues arises and environmental becomes polluted and toxic. To overcome from this, green chemistry appears, and how how we can get relief from this is described by our respected professor Sanjay Bhar. Further, there is a new topic in the research area with enormous application is nanotechnology and nanoscience. Nowadays, nanomaterials are used in different devices. We are using it as also application in medicinal purpose, particularly cancer therapy, and green synthesis can also be done. Green synthesis can also be done using nanocatalyst. In our day-to-day life, we are using lots of substances made by nanomaterials. We learn and become enriched about nanotechnology and nanoscience from Dr. Dandapat. I am sure all of we enjoy the 2 lecture session. In this situation, one announce is that for network problem, our governing body president, Minal Kandi Chakraborty, unable to deliver his introductory speech. Then I go directly to our principal madam. I request our principal madam, Dr. Sujata Bagji Banerjee, to deliver her welcome address. Then, madam, please.
Madam, please unmute korun. Mute achen apni.
Hello, am I audible?
Yes, ma'am, you are audible.
Yes. Very good afternoon, everybody. Today, very auspicious day, we meet together in a webinar organized by Department of Chemistry, Krishnath College. In this webinar named Chemistry and Nanotechnology, organized by Chemistry Department and our beloved colleague of Chemistry Department. And I welcome in this auspicious day, Mahalaya Day, Devi Durga Durgoti Nashini. She will restore our energy in our inner health. We pray to our goddess Durga in this auspicious day. And I welcome Dr. Professor Sanjay Bhar, Professor of Chemistry, Jadavpur University, Dr. Anirban Dandapat, Assistant Professor, Kumaun University, Uttarakhand. In this webinar, I give them welcome. It gives me an immense pleasure to extend a very welcome address to all of you present here, our Department of Chemistry lecturers, professors, assistant professors, and our beloved students and other college colleagues. All you are present here. I would also like to express our gratitude to our respected resource persons who have to accept our invitation as an honorable speaker in this webinar on awareness about green chemistry and nanotechnology organized by Department of Chemistry, Krishnath College. Those distinguished speakers, Professor Sanjay Bhar from Jadavpur University and Professor Anirban Dandapat from Kumaun University will deliver their speech and share their knowledge on this topic to our students. Professor Sanjay Bhar will share his knowledge on green chemistry. Title of his talk, Green Chemistry, What, Why and How. Professor Bhar is an eminent scientist in this field of synthetic organic chemistry, particularly nanoparticle catalyzed green synthesis, and published a lots of papers in reputed international journals. He is a great supervisor and was an eminent speaker of Royal Society of Chemistry, Eastern India section in 2001. He was also an excellent teacher of Indian Academy of Sciences, Bangalore 2002. Professor Dandapat will share his knowledge on nanotechnology and its impact in our lives. Dr. Dandapat is specialized in the field of nanoscience. He was published lots of papers in reputed international journals. He has got different awards like DST Inspire Faculty Award, Best Poster Award in International Conference, etc. I am sure that you will all will feel enriched with knowledge after completion of this event. I welcome you all once again to this national webinar and hope that you all will have a great time ahead. Thank you everybody, and thank you all of you with our colleagues, governing body, teachers council, and the audience, those who are listening the webinar, and welcome all our resource persons and other college colleagues. Thank you everybody. You may start your webinar, and I convey my regards to our President, Governing Body President who is not in this webinar, and also I convey my regards to our senior colleagues who are not present here, and also the our students who are listening this program. Thank you. And Sanjay, our Assistant Professor of Chemistry and Head of the Department of Chemistry, organized a very good webinar today. I convey my love and respect also to my colleagues. Thank you, everybody. Sanjay, may start your webinar now.
Thank you very much, madam, for your welcome address. Now we can go to our technical session, direct lecture session. Now we shall start our technical session 1. In this session, Professor Bhar will deliver his talk on green chemistry, what, why, and how. In this case, I request Sri Ashit Kumar Das, Assistant Professor of our Department of Chemistry, to introduce our first speaker, Professor Bhar. In this situation, I must mention one thing that Professor Bhar is the research guide of Sri Ashit Kumar Das, assistant professor of our department. So I request Ashit Kumar Das to introduce Professor Bhar. Ashit Kumar Das, please.
Can you hear me, Sanjay? Am I audible?
Yes, sir, you are audible. Continue, sir.
Good afternoon and welcome to all the participants, respected Principal Madam and IQC Coordinator, Honorable Research Person, and faculty members, and our dear students in this webinar on awareness about green chemistry and nanotechnology. It's my great honor to introduce Professor Sanjay Bhar sir as the honorable speaker in this webinar. Professor Bhar sir graduated in chemistry from Presidency College in 1987. He obtained Master of Science from University of Calcutta in 1989. He was first in first class in both BSc and MSc examination. He has recipient Certificate of Merit awarded by Council of Scientific and Industrial Research for being among 11 top candidates in chemistry in the joint CSIR UGC eligibility test in 1989. He received doctoral degree from Indian Association for the Cultivation of Science under the supervision of Professor B.C. Ranu in 1995. In that year, he joined Jadavpur University as lecturer in chemistry and started his research and teaching career. He was promoted to reader in chemistry in 2002 and currently he is professor of chemistry from 2010. His research work is focused on the development of novel methods and reagents for radio, chemo, and stereoselective organic transformation for the construction of important molecular skeletons and studies of organic reactions under solvent-free conditions in aqueous as well as other eco-compatible media, along with the use of supported reagents in light of green chemistry. He has published his research work in several national as well as internationally reputed journals. Professor Bhar sir is very excellent speaker and renowned teacher. He delivers talks at various national as well as state level symposia, teachers upgradation program, school teacher, and refresher courses for college and university teachers, popular lecture on the life and works of Acharya Prafullo Chandra Roy, as well as acted as the member of judges in KVS Regional Science Congress. Professor Bhar sir is very well known and popular on green chemistry. I am sure that our dear students behind this meeting room are eagerly waiting to hear the special lecture from Professor Bhar sir. With this brief introduction, I welcome to Professor Bhar sir to start the session. Let's start. Please.
Good afternoon, everybody. Good afternoon, everybody. Am I audible?
Yes, sir, you are audible.
Okay. Shall I start my presentation?
Yes, sir. Yes.
Thank you. So I am now sharing my screen.
One thing I want to mention, if the participant
Can
have
you see
any
the screen?
Not yet, sir.
Not so. One
Yes.
thing, if participant have queries, then you throw it in the live chat box. Then it will discuss after the lecture session.
Yes, sir, it's visible.
Yeah, is it visible?
Yes, sir, it's visible.
Okay, fine. So very good afternoon to everybody. First of all, let me thank Dr. Sujata Bakchi Banerjee, the principal of KN College, Dr. Sanjay Nath, the convener of this webinar, for inviting me to present my talk on green chemistry, and Mr. Ashit Das for kind words of introduction. At the outset, let me tell you that I have talked at several places in several occasions, but in all the cases, I have visited the place where I have delivered my talk. This is the first time I am not able to visit the spot where I am supposed to deliver this lecture, which I feel is a very premier educational institute, not only of our state, but also of our country. And I like to mention in this connection that as because we are staying in Bengal and most of the people in the audience, they can understand Bengali. So I shall speak a little bit of Bengali in order to get rid of the monotony of this 1 hour long talk. And as because I could not attend the place, I like to share the photograph of where I was supposed to be here at this point of time, but sorry, I am not there. I am here at my residence from where I am delivering my talk. So let me virtually share my presence with this very premier educational institute, Berhampur Krishnath College. একটু বাংলায় বলছি। এই ঊনবিংশ শতাব্দীতে আমাদের বাংলায় দুজন বাঙালি রানী, তারা দুজনেই বিধবা রমণী ছিলেন। ঘরে ঘরে তাদের নাম উচ্চারিত হতো। একজন হচ্ছেন রানী রাসমণি, আমরা সবাই জানি, দক্ষিণেশ্বর কালী মন্দিরের তিনি প্রতিষ্ঠাতা। এছাড়া আরো অনেক সমাজ সংস্কারক যে কাজকর্ম তখনকার দিনে হয়েছিল, সেই সমস্ত কাজকর্মে তার অংশগ্রহণ ছিল। আর আরেকজন হচ্ছেন মহারানী স্বর্ণময়ী। এই মহারানী স্বর্ণময়ী বহরমপুর কৃষ্ণনাথ কলেজের সঙ্গে তার নাম ওতপ্রোতভাবে জড়িত, আমরা সবাই জানি, আপনারা সবাই জানেন। এবং মহারানী স্বর্ণময়ী তার মানব কল্যাণে অবদানের জন্য মহারানী খেতাব শুধু পাননি, তিনি ইম্পেরিয়াল অর্ডার অফ দ্য ক্রাউন অফ ইন্ডিয়া পেয়েছিলেন। এবং সত্যি কথা বলতে কি, আমি একটা ওয়েবসাইট দেখছিলাম, মুর্শিদাবাদ ফিরে দেখা, সেখানে আমি মহারানী স্বর্ণময়ী সম্বন্ধে কিছু কথা জানতে পারলাম। বিভিন্ন শিক্ষা প্রতিষ্ঠানে তিনি অনেক অর্থ দান করেছেন। মেডিকেল কলেজের লেডি ডাফরিন হস্টেল, মহিলা ছাত্রীদের থাকবার জন্য যে ছাত্রীনিবাস, সেখানে তিনি প্রচুর অর্থ দান করেছেন। সেই ছাত্রীনিবাসের ভিত্তিপ্রস্তর স্থাপন করেছিলেন লেডি ডাফরিন। আর আপনারা সবাই জানেন যে বহরমপুর যে ওয়াটার ওয়ার্কস, পানীয় জল সরবরাহের ব্যবস্থা, সেখানে তিনি একটি বৃহৎ অংশ, সেই যে প্রকল্প, সেই প্রকল্পের খরচার একটি বৃহৎ অংশ তিনি দান করেছিলেন। সেই ব্যয়ভার তার দান করা অর্থে নির্বাহিত হয়েছিল। এবং আরো অনেক শিক্ষা প্রতিষ্ঠানে তিনি অর্থ সাহায্য করেছেন। এবং কলকাতা শহরে মহারানী স্বর্ণময়ী রোড বলে একটি রাস্তা আছে, কলকাতা 7,09,000 পোস্ট অফিস। কিন্তু একটা যে জিনিস আমি দেখতে পাইনি, সেটা হলো এই, উনি আরো একটা জায়গায় অর্থ সাহায্য করেছিলেন, কিন্তু সেই ওয়েবসাইটে সেটা উল্লেখ করা নেই। এই জায়গা থেকে আমি আমার কথা বলা শুরু করছি। এই জায়গাটা চিনতে পারছেন আপনারা কি? অবশ্য এখানে কোনো কথাবার্তা বলার বা ইন্টারাকশনের কোনো স্কোপ নেই। তা যাই হোক, আমি বুঝতে পারছি না আপনারা চিনতে পারছেন কি চিনতে পারছেন না। বলে দিই, এই জায়গাটা আমাদের আলিপুর চিড়িয়াখানায় অবস্থিত। একটি বাড়ি, অনেক দিনের পুরনো, দেখেই বুঝতে পারছেন। বাড়ি বলবো না, এটি একটি নিবাস। এইখানে কি লেখা আছে এটা হয়তো আপনারা পড়তে পাচ্ছেন না, একটু বড় করে দেখাই, একটু কষ্ট করলে বুঝতে পারবেন। এইখানে কথা লেখা আছে মুর্শিদাবাদ হাউস। চিড়িয়াখানা যখন শুরু হয়, বিভিন্ন জন্তু জানোয়ার পশু পাখিদের রাখার জন্য যে আবাসগুলো তৈরি করা হয়েছিল, সেই সময়কার প্রচুর ধনী মানুষ, রাজারা সেইখানে অর্থ সাহায্য করেছিলেন। চিড়িয়াখানা কিন্তু কেবলমাত্র মানুষের বিনোদনের জন্য সৃষ্টি হয়নি। আপনারা একটা জিনিস জানবেন, এই আলিপুর চিড়িয়াখানা কিন্তু সেই অর্থে আমাদের বাংলা তথা ভারতবর্ষে প্রাতিষ্ঠানিক গবেষণাগার বলা যেতে পারে। এর অনেক বড় ইতিহাস আমি আলোচনা করছি না, কিন্তু পাখিদের সংরক্ষণের জন্য যে মুর্শিদাবাদ হাউস তৈরি হয়েছিল, সেই মুর্শিদাবাদ হাউসে কাশিমবাজার রাজবাটি থেকে অর্থ সাহায্য এসেছিল, এবং তার পাশের যে পাখির যে আবাস, সেটি এখন সংস্কার করা হয়েছে এবং সেই ভবনটির নাম হচ্ছে স্বর্ণময়ী হাউস। এই স্বর্ণময়ী হাউসে আপনারা দেখতে পাবেন অনেক পাখি থাকে, শুধু পাখি থাকে না, এই স্বর্ণময়ী হাউসে কচ্ছপ, যারা এখন বিরল প্রজাতি হয়ে যাচ্ছে, সেই সমস্ত কচ্ছপ তাদের ডিম ফুটে বাচ্চা হয় এবং তাদেরকে লালন পালন করে তাদেরকে আবার প্রকৃতির বুকে ফিরিয়ে দেওয়া হয়, যাতে নাকি তাদের যে পপুলেশন সেটা যেন তারা বজায় রাখতে পারে। এই যে প্রাকৃতিক ভারসাম্য রক্ষার যে প্রয়াস, এই প্রয়াসে কিন্তু মহারানী স্বর্ণময়ীর আর্থিক অবদান সব সময় কৃতজ্ঞতার সঙ্গে স্মরণ করা হয়, এবং এই আবাসস্থলটিকে মহারানী স্বর্ণময়ীর নামে উৎসর্গ করে স্বর্ণময়ী হাউস বলা হয়। কেন আমি স্বর্ণময়ী হাউসের কথা এলাম, কেন আমি মহারানী স্বর্ণময়ীর এই ক্ষেত্রে অবদানের কথা এলাম? বিকজ the book one must read to learn chemistry is the book of nature. That is very, very important thing. I do not know whether you know who has told this. I shall come to it later on. Another great lady, Rachel Louise Carson. She was a marine biologist. She wrote a book, Silent Spring. This was published on 27th of September 1962. She was inspired to write this book when she found the birds, they are lying dead, floating dead on the surface of the sea water. As because she was a marine biologist, she used to visit the sea places very often. Then she started investigation, and then she found that the chemical pesticides which we use, they are detrimental to our surroundings, to the ecosystem. And she coined the title of the book, Silent Spring. A particular chapter was dedicated to the menace of DDT. What is DDT? As we all know, DDT is this molecule which is highly stable and very poorly biodegradable. When this was discovered, this was termed as the elixir of life by the then Prime Minister of England, Winston Churchill. It acts as a nerve poison that causes paralysis, convulsion, and death in insects. It is sprayed on crops to kill insect pests. It is sprayed on people as a delousing agent, that means to kill, আমাদের বাংলায় যাকে উকুন বলা হয়, to kill lice. It is sprayed on homes to destroy mosquitoes carrying malaria. Later on, number of incidents throughout the world happened which was found to be responsible due to indiscriminate use of DDT. And she dedicated one chapter in that book to DDT, where she mentioned that because of biological magnification of DDT, bioaccumulation of DDT in birds, the calcium metabolism is disturbed, so that the eggshells, which is made up of calcium carbonate, they cannot be properly formed. And if the eggshells are not properly formed, the chicks cannot develop within. So the chicks will not take birth. Naturally, with time, there will be no bird. The spring where the birds sing, if there is no bird, the spring will become silent. Whereas there is no song of any bird. That's why she coined the title of that chapter as Silent Spring, and also the coined title of that book is silent spring. She mentioned that it is not necessary to completely withdraw this helpful pesticide, but she encourages responsible and carefully managed use with an awareness of the chemical's impact on the entire ecosystem. That's a very, very serious message wherefrom everything will come out. In fact, she concludes her section on DDT in silent spraying not by urging a total ban, but with advice for spraying as little as possible to limit the development of resistance. Very important. We must remember this. The introduction of large amounts of any chemical in the environment, even to eradicate disease, has the potential for long-term and far-reaching effects that may be very difficult to predict in recent time. Therefore, adequate caution must be taken about our fragile environment. Our well-intentioned intervention all too often upsets the critical balance of nature, and in the end, we inadvertently do more harm than good. This is a phenomenon. This is the picture of fire which actually took place on a river at Ohio City. The river was so polluted with various chemicals disposed as waste. It caught fire by the interaction of those chemicals with the water of the river. We all know that water is used to extinguish the fire, but here the intensity of fire is such that it took place on the water of the river. The enormous amount of water present in the river, that is not sufficient to put it off. This figure 15274, you can have number of interesting things out of it. If you add 5 and 2, you'll get 7. But this figure bears a very sad connotation with respect to our own country. This is the number of people, as per official report, who were killed in Bhopal tragedy, which took place during the midnight of December 2nd and 3rd due to the leakage of methyl isocyanate from the factories of the Union Carbide. The greatest tragedy which has been caused by the leakage of chemicals unfortunately took place in our own country. But behind every darkness, there is a bright line. Under every grief and pine runs a joy with silk and twine. After this Bhopal tragedy, chemists all over the world, they were now starting thinking to practice chemistry in a different fashion so that it does not cause much perturbance towards the surroundings. In this pursuit, green chemistry came out with an objective to prevent pollution, sustaining the earth. And as I have mentioned, the inherent philosophy of this subject, it is also called as benign by design chemistry. And this green chemistry and technology are indispensable for the survival of our future generation. Chemists, they must pursue practical elegance. Chemical synthesis must be technically logical, intellectually logical, and technically efficient. I am not saying this word. I am taking this word from the writings of Professor Roy G. Noiri, whom probably all of you know. He has got Nobel Prize in Chemistry in 2001, sharing it with W.S. Knowles and Barry Sharpless. So a Nobel laureate, he is also putting his head in this business. So you see, you can clearly understand how much important the subject is in global perspective. Is green chemistry a chemistry of the compounds colored green? This was a question I used to face mainly from the students at various institutes. সবুজ রঙের যে কোনো জিনিস তার রসায়ন কি আমরা গ্রিন কেমিস্ট্রি বলবো? Certainly not. What is this? What is this? The crystals here. This is malachite green. I think you have prepared, the students you have prepared during your qualitative analysis while detecting benzaldehyde or N-dimethyl aniline during your first year study. There, you reacted benzaldehyde with N-dimethyl aniline in presence of concentrated sulfuric acid and an oxidizing agent. You got the formation of this green compound, which is malachite green. Remember, it is looking very beautiful green. It is extremely dangerous. It is strongly carcinogenic. It is used to look the stale vegetable fresh. Very, very carcinogenic, although it's colored green. So all green colored compounds are not green. Then why is green chemistry? The green chemistry is actually coming from this plant kingdom, which takes from the earth, then returns something to the earth, returns something which is not beneficial, but returns many things which is beneficial, and that circumvents the very minor amount of unbeneficial component which it releases. So that is the philosophy of green chemistry. Do something, try to create minimum perturbance, if possible no perturbance to the surrounding, if possible return something which is beneficial to the surrounding. Let me proceed. 12 principles of green chemistry are there. They have been proposed by Paul Anastas and John Warner. Paul Anastas and John Warner, they have written a book, Green Chemistry Theory and Practice. That is the first book internationally acclaimed on this subject. And Paul Anastas is considered to be the father of green chemistry, as he has coined this term, green chemistry. And US Environmental Protection Agency, how was it formed? It was actually formed after the movement created by Rachel Carson. Rachel Carson, she died probably in the year 1964. After that, following the spirit of his book, Silent Spring, United Environmental Protection Agency was formed. And in 1988, Rachel Carson was awarded posthumously with the Presidential Order of United States, which is the highest civilian honor of that country, just like Bharat Ratna of India. United States Environmental Protection Agency, they have incorporated 12 principles of green chemistry proposed by John Warner and Paul Anastas. You can see the principles. 12 principles are there. I am not going into the details because time span is not very long. Prevent waste, design safer chemicals and products, design less hazardous chemical synthesis. I shall try to highlight. Use renewable feedstock, use catalysts, not stoichiometric agents. Avoid chemical derivatives, maximize atomic economy. I shall come to this. Use safer solvents and reaction conditions. I shall come to this. Increase energy efficiency. Design chemicals and products to degrade after use. I shall come to this. Analyze in real time to prevent pollution and minimize the potential for accidents. Safety, safety, and safety. That is the greatest criterion of green chemistry. Green chemistry is about reducing. It talks to reduce. We are increasing everything nowadays. It talks in a different philosophy, in an anti-parallel fashion. It talks to reduce waste. How can you reduce waste? If you can reduce the use of materials, you reduce hazard, you reduce risk, you reduce energy consumption, you reduce environmental impact. Most important, if you develop a method, if you develop a technology, you have to reduce cost. Unless it is cost effective, it will not be acceptable to the greater mass. Green chemistry is about waste minimization at source, use of catalyst in place of reagents, use of non-toxic reagents, use of renewable resources, improved atom economy, and use of solvent-free or recyclable, environmentally benign solvent systems. Let me try to elaborate the points in a brief way. See, I mentioned there, here, if you go to the slide, design chemicals, the point 10, design chemicals and products to degrade after use. That was the main problem lying with DDT. It was not at all that much well biodegradable. That's why bioaccumulation took place. You see, this is an alternative. This is the flower of Chrysanthemum that is regarded, highly regarded in Japan, and that's why flag of the Emperor of Japan, the design, the motif has been chosen from that of Chrysanthemum flower. These are the compounds, pyrethrin, which are present in Chrysanthemum, and they have got very good insecticide property. Different derivatives have been prepared from pyrethrin, like cyfluthrin, transfluthrin. You know, anti-lyse agent, I mentioned about DDT, but in later on, there was found number of drawbacks of using DDT. That's why DDT has been banned in US in the year 1972. This compound, permethrin, this permethrin is an alternative delousing agent. It is costly, but it acts as alternative delousing agent. What is the advantage of this compound with respect to DDT? If you can see the structure of these compounds, the basic skeleton you will find, this is the cyclopropane ring, which is very strained. If it is cleaved, if the positive charge is located over here, that is stabilized by conjugation. If the negative charge is located over here, that is also stabilized by conjugation. It has been found the half-life of pyrethrin is only 16 hours in nature. So after 16 hours, 50% of these molecules, they are actually degraded. So problem of bioaccumulation, that is much less, but they are as efficacious as of DDT for being as insecticide, or in broader sense, pesticide. Now, Anastas and Williamson, they have written a book. They have mentioned in the book about two very important topics. One is atom economy and other is catalysis. Atom economy, Anastas termed it as foundation of the principles of green chemistry. Catalysis, he termed as fundamental area of investigation. Very important two aspects. Now, measures of reaction efficiency. One is yield. We all know very well. Actual quantity of the product achieved by theoretical quantity of the product achievable. Then comes selectivity. Yield of the desired product by amount of substrate converted. Then comes the third point. That is called as atom economy. Relative molecular mass of the desired product divided by relative molecular mass of all reactants, taking care of the stoichiometric coefficient in a balanced chemical equation. And this term atom economy was proposed by Barry Trost. Just one example. This is an example of an industrial process where maleic anhydride is prepared from benzene through oxidation using some catalysts. If you carefully look at this equation, the equation is balanced, and we have put an unconventional stoichiometric coefficient for oxygen. Why? Only to maintain the stoichiometric coefficient of the product as 1. Now, if you just calculate it, the atomic economy, the molecular rate is coming out here, and the molecular rate of benzene, and for oxygen, this 4.5, the stoichiometric coefficient is multiplied with the molecular weight, and that's why the atomic economy comes to 44.1%. What is the significance of this term? 44% of the atoms on the reactant side, they are actually consumed in the product. Remaining atoms, nearly 56%, they are lost in terms of byproducts. Can you now appreciate the importance of atom economy of the process? If the atom economy is large, if the value of the atom economy is high, then it signifies that more and more number of atoms on the reactant sides, they are incorporated in the desired product. Formation of waste, that is minimal. But that is not all. Before that, let me mention, it is very difficult to say atom economy of a process. It is possible to say atom economy of a process if the atom economy is 100%. For example, 4 plus 2 cyclic addition or electrocyclic reaction or some intramolecular rearrangements where there is no loss of any atom. I shall come to such an example later on. But this is an example where aldol condensation followed by dehydration takes place. For the first reaction, if you go to the stoichiometric coefficients and calculate the atom economy, taking the molecular weights of the reactants and products, you are getting the atom economy is 92.035%. But in the second example, the similar type of reaction is there, but the stoichiometric coefficient is different. You are getting a different value of atom economy. Unless it is 100%, you cannot call the atom economy of a process is this. You have to mention a particular reaction and then you have to say atom economy of the process is this. Then, difference between yield and atom economy. This process, the Fry's rearrangement, taking place in presence of anhydrous aluminum chloride at elevated temperature. This process has got 100% atom economy because no atom is lost from this phenyl acetate. But the yield is 35%. Most of the things which are obtained are the byproducts. So atom economy and yield, they are not going parallel. Atom economy is purely theoretical value, but yield is an experimental value which is determined by the final weight of the compounds you have prepared, and that differs from person to person. So atom economy, as because it's a theoretical value, it is independent of performance competence, but yield, it depends on performance competence. Now, regarding solvents, Pfizer company, a leading pharmaceutical company of the world, they have classified the solvents we commonly use in 3 categories. In left hand side, you are seeing the category of the preferred solvents. At the top, there is water. The middle category is usable solvents, but very careful, undesirable solvent, the right hand category, which is drawn in red. Most of the solvents we use in our day-to-day life, in course of our organic chemistry experiments, they belong to this third category. There lies the problem. The solvents we use, they need to be replaced. Actually, green chemistry pursuit is trying to find an alternative method with an objective to create minimum perturbance towards the surrounding in terms of waste formation, in terms of the using toxic reagents, all these things. And they have also proposed a solvent replacement table where I can mention 2 examples. Diethyl ether, which is extremely inflammable and carries the risk of fire, they can be replaced by tertiary methyl ether. Benzene, which is highly carcinogenic, can be replaced with toluene if it simply acts as a solvent. This is a classical reaction, organic reaction carried out in water. Remember, in the year 1980, no concept of green chemistry was there because the Bhopal tragedy took place in the year 1984. Ronald Breslow published this paper in JACS, Journal of American Chemical Society. The objective was the most complicated chemical reactions they are occurring in our biological system. The reaction medium is not DMF, not chloroform, not benzene, not ether. The reaction medium is the cellular fluid, mostly it is water. So most complicated reactions are actually taking place in aqueous condition with the help of enzymes. Can we mimic the organic reactions in aqueous medium? Under this pursuit, he carried out this reaction, the 4+2 cycloaddition reaction between cyclopentadiene and methylphenyl ketone. He has observed that in water, the rate is increased, the reaction is accelerated to a great extent with greater endoselectivity compared to other conventional organic solvents. This is a very important reaction. Industrial process. You know the use of adipic acid for the synthesis of nylon 6,6. Those people who have done practical organic chemistry classes with liquid organic samples, cyclohexanone or cyclohexanol, and tried to prepare the derivative. One of the derivative was the preparation of adipic acid, which was done by using fuming nitric acid. And those people can remember that the most important drawback of this process is the evolution of enormous amount of brown fumes of nitrogen dioxide, which is extremely toxic and carcinogenic. And this process is also followed in industry. Then think of it, for large scale preparation of adipic acid, enormous amount of fumes of nitrogen dioxide, they are coming out, and the workers there, they are exposed regularly to this nuisance atmosphere. Roy G. Noyeri, the Nobel laureate, he got Nobel Prize in 2001. Before that, he published this paper. After getting the Nobel Prize, he has published the review from which I took the quotation: green chemistry and technology is indispensable for the survival of our future generation. This is an alternative process for the preparation of adipic acid, starting from cyclohexane instead of fuming nitric acid. Here, Professor Noyeri is using hydrogen peroxide, is an eco-friendly oxidant, relatively more eco-friendly than fuming nitric acid, which is extremely corrosive. Moreover, the byproduct, which was nitrogen dioxide in case of the conventional one, highly toxic and carcinogenic. In this process, the byproduct is the most innocuous one, that is water. It's a tremendous triumph in the field of green chemistry, and it's science. It's a very, very prestigious journal with such a simple reaction, with such a big utility, great impact. It was published. Remember, during that time, he did not receive the Nobel Prize. It's not that a Nobel laureate's paper will be published. No, at that time, he was yet to receive the Nobel Prize. He proposed a mechanism like this. First, cyclohexene undergoes epoxidation to give cyclohexene oxide. That cyclohexene oxide is opened up in aqueous condition to give trans 1 to diol. This is oxidized to alpha hydroxyketone, then further oxidized to this lactol anhydride, then further oxidized to lactone. This is actually Baeyer-Villiger reaction. This step is Baeyer-Villiger oxidation. Then further oxidation to anhydride of adipic acid. Opening up of this anhydride in aqueous condition leads to the formation of adipic acid. Extremely simple reaction without emitting any obnoxious waste. Rather, the waste which was produced here is most innocuous water. This is another approach, organic photochemical reaction in solid state, no solvent, nothing. This is cinnamic acid. This is the alpha form of cinnamic acid, where the cinnamic acid molecules, they are arranged in anti-parallel fashion in the crystal lattice. If in the solid state, in absence of any solvent, it is photolyzed, the single crystal of cinnamic acid gives a single crystal of truxilic acid. This compound, two phenyl groups are located at diagonal carbons. Similarly, two carboxylic acid groups are located on diagonal carbons. They are arranged in anti-parallel fashion. But this alpha form of cinnamic acid can be converted to the beta form by forming a double salt with 1,2-diaminocyclohexane. In that case, for forming the double salt, these two carboxylate anions, they become parallelly arranged, in contrast to alpha form, where the carboxylic acid groups were anti-parallelly arranged. So in this form, the beta form, if it is photolyzed, another molecule, truxinic acid, which is the constitutional isomer of the previous one, that was obtained exclusively. This is not possible to obtain. This exclusive occurrence of these two isomeric compounds was not possible to be obtained in solution phase. That is only possible in solid state where the molecular frameworks are rigid and not free to move. This is another very interesting reaction, the intermolecular association, dimeric structure of two alpha beta unsaturated carboxylic acids. They have been written in two different colors, blue and red, but in practice, they are actually the same molecules. You see, because of this intermolecular hydrogen bonding to form this dimeric structure, these two double bonds, red and blue, they are coming close to each other. So in presence of light under photolytic condition in solid state, pi 2s plus pi 2s cycloaddition takes place. You are having the formation of this molecule exclusively with 100% yield with this particular array of the substituents. Remember, if this carboxylic acid group is converted to the methyl ester, no such reaction takes place. That shows the importance of this dimeric structure through intermolecular hydrogen bonding. Can you identify this red liquid? Looking very good. No, it's not the solution of any organic dye. This is the gold colloid which was prepared by Michael Faraday over 150 years ago. This gold sol is so stable that it is kept intact till date in the Museum of Royal Society of Chemistry. It is so stable. The first gold sol prepared in vitro by a genuine genius of science who is none other than Michael Faraday. Now, this is one reaction. We are now searching for better alternatives. This is a very common reaction. Reduction of nitro group to amino group. The most conventional method is the reduction of nitro by using tin and concentrated HCl. What you are ended up with? You are ended up with the salt of the amine. In order to get the amine free, you have to basify the solution. When you are basify the solution using an alkali, you are ended up with an enormous amount of the precipitate of tin hydroxide. And isolation of the amine from that copious amount of tin hydroxide precipitate is quite troublesome. Aniline is isolated after basidification by steam distillation. It's a cumbersome process. Whenever we talk of green chemistry, in India especially, we must mention the name of the person who has actually initiated green chemistry research in India, who was none other than Professor Brindaban Chandra Rao, Fellow of Indian Academy of Science, Fellow of Indian National Science Academy. I have put two pictures here. This is the picture resembling Professor Ranu as FSCFNA. This has been taken from the website of Indian National Science Academy. And this is the picture of Professor Ranu, the teacher, the guide. I'm fortunate enough to have him as my mentor, not only my mentor, my friend.
হ্যালো সঞ্জয় স্যার, শোনা যাচ্ছে? সঞ্জয় স্যার? স্যারের নেটওয়ার্ক ফ্রিজ করেছে, প্লিজ ওয়েট। ওকে স্যার, লেফট করে স্যার এখনই জয়েন করবেন, প্লিজ ওয়েট। সঞ্জয় নাথ স্যার শোনা যাচ্ছে? সঞ্জয় নাথ স্যার আনমিউট করবেন প্লিজ।
হ্যাঁ,
স্যারকে একটু কন্ট্যাক্ট করে দেখুন কি প্রবলেম হলো।
ঠিক আছে, দেখছি। অসিত, অসিত,
অসিত স্যার আছেন? অসিত স্যার আনমিউট করবেন।
অসিত একটু স্যারকে কন্ট্যাক্ট করে
কন্ট্যাক্ট করছি।
হ্যাঁ, দেখো একটু কি প্রবলেম হলো, একটু ফোন করো।
আই থিঙ্ক নেটওয়ার্ক কিছু ইস্যু হয়েছে।
নেটওয়ার্কের প্রবলেম হয়েছে
নেটওয়ার্কে
কিছু।
হ্যাঁ, পার্টিসিপেন্টদের একটু ওয়েট করতে বলুন, ওরা আছে।
হুম।
আচ্ছা, আমি ওনাকে ফোনেও পাচ্ছি না, নেটওয়ার্কের ভীষণ সমস্যা হচ্ছে। আরেকবার দেখছি ফোন করে, মানে
হুম হুম।
হ্যাঁ, একটু কন্ট্যাক্ট করার চেষ্টা করুন, অথবা আমাদের পার্টিসিপেন্টদের উদ্দেশ্যে সঞ্জয় স্যার একটু বলে দিন যে একটু ওয়েট
আমি বলে
করতে।
দিয়েছি, চ্যাটে লিখে দিয়েছি। হ্যাঁ, আচ্ছা, আমি এমনি বলেও দিচ্ছি। There is a network problem for resource person end, so please wait for some time. We are try to contact with sir, resource person. Please wait. We are trying to contact the resource person. There is a network problem on his end. So I requested to all participants wait for some time. অসিত পেলে?
আমি ফোন করছি, রিং হচ্ছে।
আচ্ছা আচ্ছা।
সঞ্জয় দা, উনি জয়েন হচ্ছেন, নেটওয়ার্কের সমস্যা হচ্ছে, উনি জয়েন হচ্ছেন।
হুম, ঠিক আছে। Sorry to say that there is a network problem. he will join very soon.
আচ্ছা, আমরা আরেকটু ওয়েট করি, উনি ট্রাই করছেন, আসলে নেটওয়ার্কের সমস্যার জন্য জয়েন করতে পারছেন না হয়তো, একটু ওয়েট করি।
ঠিক আছে, আমরা ওয়েট করছি। সঞ্জয় স্যার, আপনি অনির্বাণ স্যারের সঙ্গে একবার কন্ট্যাক্ট করুন, উনিও জয়েন করে যান।
হ্যাঁ, অসিত, তুমি অনির্বাণ ওই স্যারের সঙ্গে
ফোন করছি।
সঞ্জয় স্যার কোনো যদি না পারেন তাহলে আমরা ওনাকে দিয়ে স্টার্টটা করতে পারবো।
হ্যাঁ,
আচ্ছা আচ্ছা, ঠিক আছে, আমি কথা বলছি।
অনির্বাণ স্যারকে রেডি হতে বলো, জয়েন হতে বলো, কারণ এখনই শেষ হয়ে যাবে।
হ্যালো অনির্বাণ স্যার, শোনা যাচ্ছে? অনির্বাণ স্যার?
হ্যাঁ, হ্যালো হ্যালো, গুড আফটারনুন।
গুড আফটারনুন স্যার।
গুড আফটারনুন।
গুড আফটারনুন।
শোনা যাচ্ছে তাই তো?
হ্যাঁ স্যার, শোনা যাচ্ছে। অসিত স্যার, একবার সঞ্জয় স্যারের সঙ্গে একটু কন্ট্যাক্ট করার চেষ্টা করুন।
হ্যাঁ হ্যাঁ,
উনি বোধহয় চেষ্টা করছেন এখনো, কিন্তু কোনো কারণে হয়তো মানে ইয়ে করতে পারছেন না আর কি।
কি করবো,
ইন্টারনেটের সমস্যা।
স্যারকে এবার মোবাইল থেকে জয়েন করতে বলুন না। মলয়,
হ্যাঁ
মলয়,
অসিত স্যার।
হ্যাঁ হ্যাঁ হ্যাঁ,
স্যারকে মোবাইল থেকে জয়েন করতে বলুন।
হ্যাঁ স্যারকে একবার আপনি বলুন যদি মোবাইল থেকে জয়েন করতে পারেন।
ওনার সাথে আর যোগাযোগ করা যাচ্ছে না, মানে ভীষণ মানে প্রবলেম হচ্ছে। তাহলে সঞ্জয় দা, তাহলে শুরু করে দেওয়া যাক নেক্সট সেশন।
অসিত ওয়েট করবে না তাহলে?
একবার ফোনেও যদি জাস্ট ফোন করেও যদি কনক্লুডিং রিমার্ক কিছু নিয়ে যায়।
অসিত ফোনে কথা হচ্ছে না? আমি কি ফোন করব?
যদি ফোন থেকেও জয়েন করতে পারেন তাহলেও
জাস্ট ফোনে যদি কনক্লুড অ্যাট লিস্ট সেশনটা কনক্লুড করে তখন
হ্যাঁ, সেটাই আমি চেষ্টা করছি, কিন্তু ওনাকে তো পাচ্ছি না ফোনেও।
সমস্যা হয়ে গেল।
ওকে, আমরা আর 2-3 মিনিট ওয়েট করি, তারপর নয় আমরা নেক্সট সেশনে চলে যাব। স্যার যদি কোনো রকম ভাবে জয়েন না করতে পারেন।
আচ্ছা, তুই না আমাকে ফোন নাম্বারটা একবার হোয়াটসঅ্যাপ করো অসিত, আমি একবার ফোন করে চেষ্টা করছি।
হ্যাঁ স্যার, জয়েন করুন স্যার। বলছি যে উনি আবার জয়েন করছেন। উনি আসলে টেকনিক্যাল ফেলিওর হয়ে গেছে। উনি আসলে আমরা ভেবেছি উনি লেফট করে গেছেন, কিন্তু উনি বলেই যাচ্ছেন আর কি, মানে আবার উনি জয়েন করবেন আর কি। একটু ওয়েট করছি, উনি জয়েন করছেন আবার।
ওকে।
উনি এসছেন, স্যার এসছেন।
হ্যাঁ স্যার, সঞ্জয় স্যার শোনা যাচ্ছে?
হ্যাঁ শোনা যাচ্ছে। আমি কোথায় শেষ করেছিলাম একটু বলবেন?
আই থিংক স্যার আপনি ছিলেন স্লাইড নাম্বার 12।
12 তো অনেক আগে।
অনেকক্ষণ থেকেই তো আপনি লেফট।
স্লাইড নাম্বার 12 তো অনেক আগে।
আচ্ছা, 35 অ্যাট লিস্ট।
প্রফেসর রানুর কথা ইন্ট্রোডাকশন দিচ্ছেন ওই জায়গাতে দুটো ফটো।
ওই যে হ্যাঁ,
synthesis of adipic acid, green synthesis of adipic acid,
এসব তো হয়ে গেছে।
Then up to Professor Ranu came up.
প্রফেসর রানু বলেছি তাই তো?
প্রফেসর রানু।
হ্যাঁ ঠিক আছে, ঠিক
Professor
আছে।
Ranu slide. Yes, sir.
প্রফেসর রানুর ওয়ার্কটা বলেছি। Could you get my point? Did I say the work of Professor Ranu?
না, স্লাইড নাম্বার 36।
This is the work by Professor Ranu 37.
Yes,
না,
sir.
এটা বলেননি।
বলি এটা শুনতে পাওনি, বলে গেছি সব শুনতে পাওনি। এনিওয়ে, তো এই সময়টা কি অ্যালট করা যাবে নাকি আমি স্কিপ করে যাব?
না বল মানে না বললে বুঝতেই পারো না। বলুন
বলুন স্যার।
আচ্ছা ঠিক আছে। Now this is a method which was developed by Professor Ranu, and would you hear that point? Through Professor Ranu, Berhampur Kane College has been associated with this green chemistry pursuit.
No sir.
No, Professor Ranu was an ex-student of this college. He passed BSc in 1968 with honors in chemistry with first class. And then he moved to Calcutta University for his MSc study. And this is the picture of Professor Ranu that I have mentioned probably. Did I mention?
Yes, up to
Yes,
this
sir.
this
Yeah.
slide we have heard.
Yeah, this is the work. And now you see the iron nanoparticles. They have been prepared by him by using sodium borohydride as the reducing agent. And using this reducing agent, he prepared the corresponding amines chemoselectively, reducing the nitro groups without affecting the other reducing functionalities like formyl, methoxycarbonyl, cyanoazide, imide intact. So that is the very important attribute of a process, the selectivity of a process. That is very important. This is beta cyclodextrin hydrate. a very efficient recyclable catalyst. We have studied the reactions with beta-cyclodextrin hydrate. In 2016, my student, Dr. Abhishek Ghotok, who is a teacher and assistant professor of APJ Abdul Kalam Government College, he has developed a method for this reaction where 2H chromine systems were produced using beta-cyclodextrin hydrate in aqueous condition at 60 degrees centigrade. Why the temperature is kept 60 degrees centigrade? You know, homogeneous catalysis. Homogeneous catalysis, the catalysts are soluble in the reaction medium. All the catalytic molecules, they are coming in contact to all the reacting substrates. But in heterogeneous catalysis, the substrates, they are present in solution, but the catalyst, they are remaining insoluble, being adsorbed on a support which is immiscible with the reaction medium. So only the catalytic species present on the support, they are interacting with the species substrate molecules present in the solution. That is one limitation of heterogeneous catalysis. But there is an operational advantage of heterogeneous catalysis. In homogeneous catalysis, the catalyst molecules, they are soluble along with the reactants and products in the reaction medium. After removal of the solvent, during the isolation of the product, the catalysts are also contaminated with the product. Isolation, separation and purification of the catalyst and product, vice versa, that becomes a little bit cumbersome. Efficient recovery of the catalyst and its separation, that is not often possible. In case of heterogeneous catalysis, this technical problem is overcome because the catalysts can be separated simply by filtration. The products are not contaminated with the catalytic species unless and until there is small amount of leaching is there. Number of molecules have been prepared by this method. I was showing this picture from my own lab. You can see this is beta-cyclodextrin hydrate in the vessel. Now we have added water at room temperature. It is insoluble. Temperature is elevated. Solvent, our organic substrate is added. It becomes soluble, clear solution. Now this beta-cyclodextrin hydrate is behaving like homogeneous catalysis. The reaction is going on. You see the products are formed. The solution is still clear because at 60 degrees centigrade it is soluble. Then it is cooled in ice. The catalyst is separated from the reaction mixture in the form of precipitate. We have added an eco-friendly solution, ethyl acetate, eco-friendly solvent, ethyl acetate to this reaction medium. The organic products become soluble. It floats up, leaving the catalyst settled down in the aqueous medium. It can be easily separated by filtration and recycled. These are the selectivity studies. I am not pondering over this. This is another example, another application of beta-cyclodextrin hydrate as catalyst, which has appeared very recently in Tetrahedron Letters. This has been done by Sri Ashit Kumar Das, assistant professor of Berhampur KN College. So you can see Berhampur KN College is associated in different ways, starting from Maharani Swarnamoyi, ending through Professor V.C. Ranu, ending to Ashit Das, and many more students and teachers probably whom I do not know in the business of this green chemistry. You see, this has been done by Sri Ashit Das, where you can see the formation of this bis-indollyl methane that is taking place chemoselectively, involving the more electrophilic aldehyde group, leaving behind the keto group intact. Number of molecules he has prepared. This is the recycling study. Following the same protocol, the experimental procedure I have already shown. Am I clearly audible and visible?
Yes, sir.
Please
Continue.
Now,
Yes, sir,
this
continue.
is the intramolecular and intermolecular competition studies. This is the intermolecular competition experiment. You can see equimolecular amount of aldehyde and ketone is present there. Ketone is left behind, only the aldehyde is reacting. You are ended up with this reaction mixture. Here in the same molecule, you can have both the keto and the aldehyde groups, the more electrophilic aldehyde that is reacting chemoselectively, leaving behind the less electrophilic keto group intact. This is an important attribute apart from recyclability, less toxicity of the catalyst. The byproduct is the most innocuous one, that is water, and atom economy is also very high. Besides all these attributes, this is a very strong attribute of this method, of this protocol for the preparation of bis-indolyl methane. After a lot of studies, a mechanism has been proposed where the initial polarization of the aldehyde is actually speculated through more acidic hydrogen of water molecules present in the cavity of beta-cyclodextrin hydrate. And that's why with beta-cyclodextrin, the reaction was quite sluggish, but with beta-cyclodextrin hydrate, the reaction was quite efficient. This is a green version from the biological system. You know the benzoin condensation that takes place using potassium cyanide, but potassium cyanide is severely toxic. This is the green version. Reaction mechanism is very important thing. What happens when potassium cyanide is reacting with benzaldehyde? Umpolung occurs, formal reversion of normal polarity. The same phenomenon of umpolung occurs using thiamine hydrochloride in biological system when pyruvic acid is oxidatively decarboxylated to acetyl coenzyme A. This umpolung phenomenon has been exploited for this acyl condensation with benzaldehyde. The advantage of this green version is that there is a limitation of conventional benzoin condensation using KCN, where only aromatic aldehydes participate. But in case of thiamine hydrochloride, this is nothing but vitamin B1. Using vitamin B1, both aromatic and aliphatic aldehydes, they participate in this acyl condensation. So this is the message by Roy G. Noyeri, where he emphasizes that it is not merely an issue inside the laboratory, it has got a broader social perspective. The biggest challenge of green chemistry is to use its rules in practice. If it be absolutely impracticable, no theory is of any value except as intellectual gymnastics. It has been said by a person who has also said, the book one must read to learn chemistry is the book of nature, which I have mentioned towards the early part of my talk. He never practiced science professionally, but he was invited to become the first director of Indian Institute of Science at Bangalore by Jamshedji Tata. He is none other than Swami Vivekananda. Following this philosophy, green chemistry in the classroom becomes very important. In this connection, I like to mention that detection of special elements, which we do in our practical classes, we do with metallic sodium. All of us are aware with the hazard of using metallic sodium. It has got the risk of explosion or getting caught fire, especially when taken in excess. All these problems can be overcome if one uses zinc sodium carbonate in place of metallic sodium, as there is no risk of the explosion or getting caught fire. No additional precaution is needed during its storage for a long period of time, because the sodium that is to be stored under oil to avoid the contact with atmospheric moisture and oxygen. But here, nothing is needed. It can simply be stored in a plastic container, in a capped plastic container. And very important, with aqueous solution of organic compounds, you cannot do the special element detection using metallic sodium. But with this zinc sodium carbonate mixture, you can do this, because there is no risk of getting caught fire or explosion in contact with water. This is a very good example of green reaction which can be practiced in the lab without using any organic solvent. Grinding benzyl with solid KOH heating it at 90 degrees centigrade on a steam bath, and after that dissolve the entire mass in water, acidify this, you will get beautiful crystals of benzoic acid. You filter it, you dispose the water as waste. Can you say which is there in water? KCl, potassium chloride. This is present in water. This aqueous solution can act as a fertilizer for flowering plants because they need potassium. The flowering plants, they need potassium. You see, during our process, just like plants, we have generated the waste which is beneficial to the surrounding. It's an example of a super green process. So green chemistry is not a solution to all environmental problems, but the most fundamental approach to prevent pollution. You can't cross the sea merely by standing and staring at water. In order to cross the sea, you have to jump into it and swim across. You can face a lot of obstacles, but you have to learn how to overcome these obstacles, and then and only then you can reach to the other side of the sea. That has been said by Gurudev Rabindranath Tagore. Paul Anastas said, green chemistry is a new science. One definition of the word green is young, fresh, and new. This is the meaning of green in green chemistry. So the take-home message is think green, and as because this is the science which is new, it needs young, fresh, and new minds. Our students are there who are young, who are fresh in their thoughts and action. We have lot of expectations on them. With that expectations of rising stars in the field of this very important aspect of scientific endeavor throughout the globe in future, let me thank all of you for your kind patience. Thank you very much.
Thank you, sir, for your nice presentation. So thank you. Now we will start our question and answer session.
Okay.
There is one question. Except biofertilizer, do the agro-based chemicals have their green counterparts?
Chat box.
Except biofertilizer,
So, in my chat box, nothing is there.
chemicals have their green counterparts. No, sir, YouTube chat box.
Huh?
YouTube chat box. There is a question. YouTube chat
Where
box.
is it? Oh, you
There
just
is
tell
question
me
from-
the question. I am trying to answer. You tell me the question.
Okay, sir. There is a question from Ipsita Bhattacharya. Except biofertilizer, do the agro-based chemicals have their green counterparts?
Agro-based chemicals. One green
Agro-based chemicals
counterpart
have their
is, one green counterpart is always there because that is obtained from the natural source. In most often cases, the commodities which are obtained from the natural source, they are less dangerous than the compounds which we artificially prepare. Just for example, the permethrin, which I have mentioned, this pyrethrin, the basic compounds, they are obtained from Chrysanthemum. You see, the risk of bioaccumulation in case of pyrethrin, that is much less than our man-made compound DDT. So this is happening in most of the cases.
Okay, sir. Thank you.
Any
sir.
other question?
There is another question from SK Das. There is another question from SK Das. Difference between green chemistry and sustainable chemistry?
Green chemistry, sustainable chemistry. The main objective of green chemistry is to prevent pollution sustaining the earth. So if there is no sustainability, there is no green chemistry. In the very definition of green chemistry, it has been mentioned in my slide. Green chemistry has the objective to prevent pollution sustaining the earth. Shall I show this? Can you see the slides?
Yes, sir.
Yes, sir.
Yes, in this definition it is there. Sustainable chemistry, it must be. As because time is not very long, I cannot go to the definition of sustainability, the conditions and all these things. That is something different. Okay, fine. I have tried to give an exposure of the entire arena of green chemistry from different angles. Anyway, any other question?
No, sir, there is no more question. Thank you
Okay.
for giving your valuable time and share your knowledge with us. Thank you, sir.
Actually, I am very sorry because I couldn't understand that I was
Sanjay,
disconnected
please
for some time.
Our next
Because when I talk, I do not care to any telephone call or anything from surroundings. I am totally focused to what I am talking about. That's why, although some ringing were there, probably, yeah, Mr. Dash was trying probably for
I'm trying to connect with you.
several times, but I could not get it. Sorry for this, but I think I could serve my purpose, although it has been delayed a little bit because of technical problem. And that is the difference of the contact mode and virtual platform. In contact mode, this type of interruptions are not generally occurring. But here in virtual mode, these interruptions are very much frequent, very, very frequent. And that creates delay in the proceedings and all these things, irritation, impatience among the audience, all these things. So thank you very much for bearing me in spite of this problem. And thank you once again for your kind patience and inviting me to deliver my talk to this program, which has been organized by Kane College. As I have mentioned probably in the talk, Kane College is strongly associated with this green chemistry business. Starting from Rani Sharma, Maharani Sharnoyi, through Professor V.C. Ranu, through Mr. Ashit Das, and I do not know, so many teachers, so many students were associated with this college. They might be somewhere practicing this. And I am really feeling proud to deliver this talk, sharing some of my views. Why is green chemistry important? What is green chemistry? And how it can be practiced to the people associated with this prestigious educational institute of our country. Thank you very much. Thank you once again.
Thank you, sir.
Thank you, sir. Thank you for your nice presentation.
So,
It must
may I
be
leave now?
Yes, sir.
Yes.
Thank you. If situation permits, if future tells, then probably I shall have some opportunity to visit your place physically, not virtually.
Absolutely, sir.
Yes,
Absolutely.
Okay. Thank you very much.
We hope to arrange such a program. We can arrange such a program. Thank you, sir. It must
Thank
be
you.
benefited to us.
Yes. Thank you.
Due to
So I am
technical
leaving.
problem, yes, sir. Due to some technical problem, now we go to the session. Technical. In this session, lecture will be delivered by Dr. Dandapat, who will talk on technology and its impact in our. I request Dr. Shabuni Barman, Department of History of on the Shabuni Barman, ma'am, please.
Yes, can I start?
Please introduce.
Yes.
Good afternoon and welcome everyone once again to our webinar. It's my privilege to introduce our next speaker of our second technical session, Dr. Anirban Dandapat, who is currently working as an assistant professor at Kumaun University, Nainital. Before his lecture, I will give very brief introduction about him. Dr. Dandapat has joined as a CSIR GRF at CSIR Central Glass and Ceramic Research Institute, Kolkata, and awarded PhD degree from Jadavpur University in 2013 in nanomaterials. Then he moved to NTU Singapore for his first PDF and then to the Hebrew University of Jerusalem for second PDF. And in 2016, he came back to India and joined as an inspired faculty at Kumaun University. Till the date, he supervised 7 master's theses, and now currently 4 doctoral students working under him. And his research work is mainly focused on development of different nanomaterials of for catalysis, photocatalysis, water purification, antibacterial activities, and waste management. He already published 3 book chapters, and he has lots of around 30 research papers in reputed international publications, journals, and he is also acting as a PI and co-PI in different research projects. One thing I want to highlight is that Professor Dandapat is working as a co-PI of research project of 3.5 crores with Nainital municipality to establish Nainital as a cleanest city in the country. Now, I think everyone is waiting, eagerly waiting for his lecture. I request Dr. Dandapat to start his lecture, and today's topic of lecture is nanotechnology and its impact in our lives. I request Dr. Dandapat to start the session. Please, sir.
Okay, thank you, ma'am. Am I audible?
Yes, yes.
Okay, thank you, ma'am, for your kind introduction. I like to thank Principal ma'am and all other organizers, especially the faculties of Department of Chemistry, Kent College, for organizing such a nice program. Especially what I came to know that this is focused on the BSc students or MSc students to motivate them in research field on the topic on two current topics, green chemistry and nanotechnology. So I feel privileged to be a part of this program, and thank you all the organizers for giving me the opportunity to share some of my views in this topic. So shall I start presentation? Can you see my slides?
Yes, sir. Yes, sir. It's visible. Make it full screen, sir.
Okay. Since just I came to know that most of the major portion of the participants are from BSc backgrounds, so I'm not going to much details of my research. Rather, just I am going to give you the overview of nanotechnology and its impact in our life. Means how it is, how we are surrounded by nanotechnology. So first of all, so these are brief contents about the introductions of nanotechnology, different types of nanomaterials, how we will synthesize them, their properties, and their impacts, applications in our lives. So first of all, what is nano? Basically, this nano term comes from a Greek word derp, means little old man. So it indicates extreme smallness. Nano may be of anything. If nanometer, then it will be 1 billionth of a meter, or if it is nanoliter, 1 billionth of a liter. 1 billion means around 100 crores. So just think of, if it will be 1 part of 1 billion, means 1000 crores. So typically different bacteria or viruses are around 75 to 100 nanometer in this range, and our human hair, it is 100,000 of a nanometer. And if we think of atoms are in the level of few angstroms. So hardly 10 to 15 atoms make 1 nanometer. So if we think how small it is, if we compare a small football and compare with the whole world, how small it is. The same way, if we go towards the lower dimension, a nanoparticle is even smaller than a football in this ratio. Means if বিশাল পৃথিবীর রেসপেক্টে একটা ফুটবল যতটা ছোট, তার থেকেও একটা এই ফুটবলের থেকে তার থেকেও বেশি পরিমাণে ছোট একটা ন্যানো পার্টিকলস। So what is nanotechnology? Basically, this is an emerging area of science and technology that conducted at atomic or molecular level in the length of nanoscale. So it can control or manipulate or engineer the materials at atomic or molecular scale. Normally, we are considering nanoparticles have dimension around 1 to 100 nanometer. Means so we can say any particles as nanoparticles if at least its one dimension should be less than 100 nanometer. Means suppose if it is spherical, all the dimension will be same, right? So its diameter will be less than 100 nanometer. But if it is suppose wires or rods, tubes, so at least its one dimension, at least its width or height should be less than 100 nanometer. Its length may be greater than this, but at least in one dimension it should be less than 100 nanometer. So basically it is not chemistry, it is not pure chemistry or pure physics, biology, theory, or an engineering. It is basically combination of all the things. It is an interdisciplinary. So how it comes, actually, if we show that modern origin of nanotechnology is contributed to Professor Richard Feynman. Actually, in the year 1959, he gave an idea. Basically, he gave a talk on this title, "There is plenty of room at the bottom." Means if we see any buildings, so towards the bottom part, usually more number of rooms are there, right? So basically, see, he gave an idea that if we go towards the bottom portion, means towards smaller portion, then there will be much more room, much more option to engineer the things so that we can get much more benefit. And the term nanotechnology actually comes actually given by Professor Norio Taniguchi in the year 1974. Later, so these are actually hypothetical things, but to understand, to visualize the nanoparticles, so we need some microscope, some high resolution microscope. So first, actually, IBM group of researchers, they built this scanning tunneling microscopy, by which they saw some nanoparticles are there. And this is the first image they took. This is on their name of their company, IBM. Thereafter, several nanoparticles, several breakthroughs are coming in this field, like discovery of fullerenes C60. For this discovery, Professor Smalley, Professor Karl, and Professor Kroto received Nobel Prize, I think in the year 1996. And also some other important nanomaterials like carbon nanotubes by Japanese physicist Professor Somio Ijima, and graphene by Professor Jim and Novoselo. Actually, for graphene related works also they received Nobel Prize in the year, I think, 2010. So basically, these are different nanomaterials, and also thereafter several other microscopy come to visualize the nanoparticles, their size, their shape, how they look like. And so just one question may arise: is it the new technology? No, actually, previously in the very long back, in the year 400 AD, also in that time also there exist some nanoparticles. So this kind of this is basically the very famous Lycurgus cup. This image is actually of King Lycurgus. According to his name, this cup are known as Lycurgus cup, and it is kept in British Museum. See, if on the reflected light, if you just put a light from the front side, and if light reflected from the cup, you will see some greenish colored cup. But if you put light behind the cup, so in transmittance light, basically you will see some reddish color. Basically, initially it's maybe this kind of blue, gradually it is turning to red. If when the light will comes from inside or from opposite side. So later, in that time they don't know it is nanoparticles, but later on, just researchers found that this contains some nano gold or nano silver nanoparticles. And in 500 AB also, means during Maya civilization, so Romans are this type of sculpture, this type of glass pots, those are using, those also contain different nanoparticles. In ancient Chinese culture also, this kind of beautiful plates, porcelain plates, different glass materials are using, containing different, especially gold and silver nanoparticles. So how we can classify the nanomaterials? Broadly, we can classify into 4 different types. Zero dimensional means it should be very small, means nanoparticles or quantum dots, means extremely within size 2 to 10 nanometer in this range. And one dimensional means it is like rod shaped, or it is wires, or it is a tube shape. And two-dimensional nanostructures are sheet-like plates, thin films, or graphene, these sheet-like structures. And three-dimensional nanostructures contains basically which will have size in the along the 3 dimensions, means it will have some length, some width, some height. So in all dimensions, maybe it will maybe cubic shaped particles, it may be prism shaped particles, or all different 3D shaped particles. Among these, so just I am mentioning these 3: fullerenes, carbon nanotubes, and graphene. This special means basically these are nowadays in everywhere these nanomaterials are being used. So whenever we are coming from bulk, big material, to smaller particles, usually in smaller particles, nano stage, only few number of atoms are there, right? If we compare with bigger particles, bulk materials, so when we are coming to very small size, basically its different its properties are enormously changing. The properties means physical, chemical, electrical, mechanical, optical, all different properties are enormously changing. So how one of the major concern is due to the enormous increase in their surface area. See, suppose this one is one cube, its one side length is basically 2L. So total area of one side will be 4L square, right? And it has cube have total 6 sides. So total surface area of this cube is 24L square. But if you cut from all sides, in just if you equally divide, then we will get this 8 cubes, and each cubes will have one side length L. And so in each cube, one side area of one side will be L square, and total area of one cube will be 6L square. And so total area of surface area of all the 8 cubes will be total 48L square. So if we just cut one cube into just equal parts from all the sides, so just surface area is just becomes doubled. So 24 to 48. Similarly, if we further cut in this individual cubes into the smaller portion, further surface area will increase. Just imagine we have a 5 cubic nanometer cubes, means its volume is 5 nanometer cube. Sorry, 5 centimeter cube. So basically, so each side will have around 1.7 centimeter, means around like dimension of like on Ludo dice. So if we cut this and cut it 24 times from all the different all the sides, and we will end up with individual smaller nanoparticle cubes having 1 nanometer side. And if we calculate their area, it can cover the whole area of a football ground. Like one Ludo dice, if we cut them into small into nanometer size cubes, then it can cover the whole area of Eden Gardens or whole area of Johar Triangle. See how much surface area increasing. Just small Ludo dice can cover the whole area of a football ground or cricket ground. So depending on their size, their different properties are enormously changing, like optical properties, band gap, surface reactivity, specific heat, melting point. But I am going to only sticking to optical properties, which will be easier to understand. So see, this is one gold, bulk gold, what we are wearing. So basically this is bulk gold, but when we will come to a nano portion, so it's depending on its size or shape, its color may be different. It is golden yellow. It was initially in the bulk state golden yellow color, but when it will come to the nano stage, basically its color may be anything. You can tune their color from any color: red, magenta, purple, yellow, blue, anything. Purple, blue, depending on its size and shape. So basically these, in this order, the size of the particles are gradually increasing, so it becomes from red to blue. And why this color comes, actually I'm not going to details. Still I'm giving an idea that when the particles are very small, means in the size of few nanometers, so it will be comparable with the wavelength of light. So when so in that condition, basically when the size of the particles are very less, in that condition, in the electrons, surface electrons of the nanoparticles are continuously oscillating. When that oscillating frequency will match with the incoming light frequency, then there will be some resonance, and that for that resonance basically some absorption will be there. So if it can absorb the visible, means certain portion of the visible light, then we will see some color. Anything why we see color, any material, because it can absorb certain portion of the visible light, and the complementary color we are seeing, right? So similar way, nanoparticle, depending on its size and shape, basically it can absorb certain portion of visible light and complementary color it is showing. Similarly, if we just tune its shape, different, see this is spherical or this is rod shaped particles, it circuits Kalman resonance, means this absorption position will change and also color will be changing. And so how we can achieve? There are two broad ways. One is top-down approach, and another one is bottom-up approach. Top-down means we have some big particles, then we will split it, we will cut it and cut, and finally we will end up with very smaller nanoparticles. And another approach is bottom-up approach. So we will start from atom level, then they will assemble or to form some cluster and finally some nanoparticles. And considering these two approaches, there are several methods are there. Few of them may be chemical vapor deposition, physical vapor deposition, microwave synthesis, solvothermal synthesis, solid synthesis, green synthesis, chemical etching, mechanical cutting, ball milling, all different other procedures. Lot of other procedures are there, but nowadays green synthesis is much more fascinating, because actually green synthesis means here I am concentrating on synthesis procedure, just utilizing plant source or some bacteria or fungus extract, so that it will not be harmful for our environment, or even if it is applied in our body, it will not be toxic for our body. So basically in chemical method, basically different chemical surfactants are being used. Instead of those, we are using different plant extract or different bacterial extract or fungal extract. So I'm not going to details, but so there are several characterization techniques should be there, whether the nanoparticles have been synthesized or what is its shape, size. So different spectroscopy may be used, or the main important thing is electron microscopy studies. So to visualize how its size, how its shape, we need to know their basically to know their size, shape. Basically we need different electron microscopy, like scanning electron microscopy, transmission electron microscopy, a lot of other microscopies are there. So these are some nanoparticles what I have synthesized using bottom-up approach. So these are different nanoparticles, highly uniform nanoparticles. This is all are gold nanoparticles. So spherical, triangular, cubic shaped, all different nanoparticles. These are different silver nanostructures. I'm not going to their synthetic details. These are different platinum, palladium, or some bimetallic means. So inside the core is gold nanorods, and upper that basically one cell coating of palladium is there. Palladium is cell. In this nanostructure, basically the palladium cell is continuous, and here it is highly nanostructured. Further nanostructures are there. This is also gold on platinum. The core portion is gold nanorods, and platinum is just decorated just above the gold. Basically, we are tuning or their composition, their morphology for different applications. Mainly, I have used for different catalytic mechanism, catalytic process, so that it can catalyze selectively, or its yield also increasing. And this one was a dream project, as mentioned by Nan during the interaction section, basically during the introduction section. So we are actually in this project, we are collecting all the garbages waste from our Nainital city, and then converting them into different nanomaterials, mainly carbon-based nanomaterials. It may be graphene, carbon nanotubes, or quantum dots, or LPG gas, diesel, petrol. This kind of value-added products will be synthesized using the garbage. And we have designed one equipment, universal waste recycle machine, and for that actually we got funded from Ministry of Environment, Government of India. So now I'm coming to the application parts. So how we are surrounded by nanotechnology everywhere. It may be energy related applications, it may be electronics, automobile, ITs, medical purposes, it may be chemistry on environment related applications, military and security applications, some consumer goods like cosmetic industry, some food industry, textile industry, car, everywhere is nanotechnology. Just I am coming few of their examples. How much time do I left? Okay, around 25 minutes more, right? So now I'm coming to the application. So this is energy related application, means now we know. So there is a shortage of fossil fuels like petroleum products or petroleum sources or some coal sources. So we are in search of alternate energy sources, right? So in this area, we all know the energy means energy of solar can be stored and converted into electrical energy, so that we can use as fuel also. So photovoltaic solar cell is very common applications, and wind energy, hydrogen generation, fuel cell, everywhere is nanotechnology. Just I'm coming to photovoltaic solar cells. Basically, this kind of solar plates are very common. So especially in rural areas also, this kind of solar cells are using, especially where there is no electricity. So in my childhood also, I was in our home, this kind of solar plates are there. So usually traditional solar cells contains silicon based technology. But nowadays, instead of silicon based traditional solar cell, basically nowadays dye-sensitized solar cell are being used, where basically if we compare with conventional photovoltaic cell, so basically the cost will be less, and also see very much flexible. Within plastic coating, plastic sheet also, we can give one coating and we can make one cell. So basically it is cost is lesser, it is more compact, more efficient, and the most important thing is it can be useful even in cloudy days. So the main drawback of conventional photovoltaic cell is basically that will be activated under sunlight, but in absence of sunlight also we can store solar power and convert it into electricity energy, basically by using dye-sensitized solar cells. So these are conventional solar energy called solar cells, and nowadays these are basically dye-sensitized solar cell. Since it is it is transparent, it can be useful in window seat also. So basically throughout the daylight it will be charged, and we can use electricity in the evening, in the night, throughout the day also. And some other for different battery technology to increase its efficiency, different carbon coated silicon nanowires, carbon nanotubes, or different nanomaterials, other nanomaterials are being used. And another alternate energy is hydrogen energy. So initially it was thought that it is very difficult to split water, right? But with the progress of nanotechnology, basically using different nano catalysts, this water can be splitted into oxygen and hydrogen, and those hydrogen could be stored and could be used as fuel for car, for other electricity, to carry chemical plant or different other industrial use also. So by using basically different nano catalysts, either photocatalytically using sunlight or using some electrocatalyst based, means electrocatalysis, we can split water and convert it into hydrogen gas fuels. Now to the electronics and communication industry, everywhere is nanotechnology. So CNT and carbon nanotube based interconnect wires, different diode transistors are there. So whatever we are using, data storage, hard disk, flash disks, everywhere is nanotechnology. And so I'm coming few applications. So nowadays, whenever we are going to buy some laptops, computer, we are just looking for some better processor, right? So give me i3, i5, i7, this kind of things. So basically what happens in the with the progress of nanotechnology, basically within the processor, small transistors are there, and within this transistor, this kind of gate gap is there. So when this gap is decreasing with the advent of basically nanotechnology, so basically within the same processor, more number of transistors could be packed, and so its electron mobility and higher dielectric constant values also increasing, and So basically, same process means within the same dimension, the processor becomes much more effective. And this just think in the year 40 years back, 2 GB hard disk was this much big and around 30 to 40 kilogram big. But around in 90s, maybe it is relatively smaller. So in 2010, we are using this kind of pen drive for 2 GB. Nowadays, we can just 1 TB, few TBs also we can store in very small area. So these are different memory chips we are using in our mobiles also. So again, in the display panels means it may be a TV, computer. So basically in around 20 years back, we are using so much big TV screens and a lot of cathode rays tubes are there. But nowadays the screen becomes very small, right? Again, this is due to the progress of nanotechnology. Only few layers conducting this kind of materials give you one very thin, but it will improve your display quality. It is reduce your power consumption. It is cost effective and extremely handy to carry also, right? So now we are looking for this kind of easy technology. And in biomedical industry also, everywhere is nanotechnology. So for drug delivery, for biosensing, for brain surgery, where traditional medicine cannot reach, basically we are using nanorobot for brain surgery. And for cancer therapy also, very common there is to use nanotechnology. Usually for cancer therapy, the traditional things are using like radiotherapy and chemotherapy, right? So basically in that, the major drawback is that those radiotherapy and chemotherapy can kill the healthy cells also. It can kill the cancerous cell, but it can also kill the healthy cells. But since the nanoparticles are very tiny, even much smaller than our cells also, so it can and also it has very good sensing capability, so that it can target the particular cancer cell and it can kill. So one very small video by National Cancer Institute, NIH US. So they just try to establish, try to give their views how nanotechnology is being used in cancer.
Imagine something 80,000 times smaller than the breadth of a ridge on a fingertip, unlocking a new frontier into cancer research. Nanotechnology, the science of building small, is changing the way we look at cancer. More importantly, the way we look at diagnosis and treatment. Nanotechnology allows researchers to build new tools that are actually smaller than cells, giving them the opportunity to attack cancer at the cellular and genetic level. This technology not only enables health practitioners to detect cancer earlier, but also holds the promise of stopping cancer before it even develops. This revolutionary approach is so precise, doctors will be able to design a unique treatment for an individual's own medical and genetic profile. Based on computer chip technology, diagnostic devices such as nanoarrays are thousands of times more sensitive and accurate than current techniques. Because of their size, multiple lab tests can be done more rapidly and at a much lower cost, using one nano device instead of many. Nanoshells can be linked to antibodies that recognize tumor cells. Once they are taken up by the cancer cells, near-infrared light is applied, killing only the tumor and leaving neighboring healthy cells intact. Scientists are engineering nanoparticles such as dendrimers to seek out and destroy cancer cells. This amazing technology can be customized for targeted drug delivery, improved imaging, and near real-time confirmation of cancer cell death. Moving research from bench to bedside is an important goal of the National Cancer Institute's Alliance for Nanotechnology in Cancer. A collaborative plan is underway to share research and development information across scientific disciplines and around the world. As biomedical applications of nanotechnology evolve, scientists are ensuring that nano devices are safe for both the body and the environment. The National Cancer Institute is optimistic that through coordinated and responsible development, nanotechnology will dramatically change cancer patient care. The science is at our fingertips.
Okay, coming to the forensic investigation. Basically, for forensic investigation, investigating officers first look at where is the latent fingerprint, right? So basically, in our hand, we have some, in our fingers, basically, due to some body oil transfer and also some sweat, basically, if the suspect person holds something in the crime scene, basically, some fingerprints will be there. So latent fingerprints are basically that are invisible at naked eye, but can be visible by certain employing certain technology. But usually the conventional fingerprint powders give some impression, but there is some drawback, like it can also adhere in the surface. So it is difficult to get very clear image of the fingerprints. But being very small nanoparticles, it can detect, it can attach selectively on the fingerprint region and give very clear impression of the fingerprint. So this one was recent work. Actually, they used photoluminescent cadmium sulfide semiconductor nanocatalyst, basically nanocrystals, to develop this kind of fingerprints. And to estimate also the time of death, usually the conventional approach with post-mortem reports uses algor mortis, rigor mortis, or some bowel content, stomach content, and also color of eyes. Lot of detailed procedures are there. But scientists found that there is a very good approach that in our eyeball, basically behind the lens, some transparent jelly-like thing, vitreous humor are there. So basically, within the vitreous humor, after death, basically up to around 100 hours, gradually the different amino acids are increasing, concentration are increasing. So basically, so they are in this work, basically they found that cysteine concentration is gradually increasing. So by using silver nanoparticles, they try to just give one just a standard plot, like after what time, what concentration of this cysteine will be there, and depending on cysteine concentration, this color of the nanoparticles will also change. So basically, by detecting the color intensity, that could be possible by using some software in our smartphone also. So within few seconds or few minutes, we can detect we can predict how much time he lived, or he dead, means he or she dead. So we can detect time of death by using nanotechnology. Also, there are several other approaches. This is just one approach. And in agriculture also, agriculture field, just in different parts, different nanoparticles are being used. During the seedling process, copper oxide nanoparticles are very common. During their growth, different nanoparticles are being used so that it can show some antibacterial, antifungal, or antiviral activities. And also it can be nowadays nanoparticles can reduce, basically can replace different pesticides or herbicides, so that it can grow the plants in a much better way. And also by secreting different by facilitating different enzymes, basically it can grow the size of the fruits, size of the vegetables also. So in food industry also, everywhere is nanotechnology, starting from food processing to food packaging, and different nano additives are used for to improve their nutritional values. And for packaging, basically different antibacterial coatings are used in the packages, so that no fungus or no bacteria can grow. And smart packaging technology today's date, basically it can, suppose if fungus is grown, then color of the package may be changed. So we can just, after visual inspection, we can see that whether the food is okay or not. So smart packaging systems are also there, using different nanowire sensors, basically. And in cosmetic industry also, everywhere is, see, we are using different sunscreen, right? especially those sunscreen contains titanium oxide or zinc oxide nanoparticles, which can protect our face from sunlight, means from basically UV, to protect the UV rays. And also in anti-aging creams, we are using liposome nanoparticles. In perfumes, we are using solid lipid nanoparticles, nano emulsions. And in mascara, ladies, what they are using, basically different hyperbranched polymer nanoparticles are being used. And in glass industry, means basically different, suppose cakes, or if we are using suppose glass, this is one normal glass. So this kind of, so suppose when we are traveling, especially in the night, basically if some car is coming from opposite side, if we are using simple glass, basically strong reflection from those car will be there, right? So it will be difficult to see the road, and also so there might be some accident also, right? But if we use some anti-reflective coatings, nowadays if you go to any shop for glass buying glass, they will just ask to take anti-reflective coatings. Okay, so what is the benefit? Basically we can reduce the reflections, and also we can see clear images, so that we can follow our path. Also if we walk, similar kind of problem might be there. And photochromic coating, also we are using different glasses, so that in the inside the room it will be transparent. When we will go outside and the sun, under sunlight, it will change its color, and so it will be comfortable for our eyes. And similar kind of coating could be useful for glass, for window also in our buildings, so that in the morning time, in the night time, it will be transparent. But when at the noon time, when there is much sunlight outside, then it will show some dark, it will becomes dark color, so that it will maintain some comfortable level. And nowadays this kind of smart window technology are also coming using nanotechnology. Basically in summer days, basically the IR rays, especially, which causes which increase our means temperature of the room, basically that will be reflected by the window, and in cold times, basically that can transmit and warm our room and keep our room warm. So basically it can act as air conditioning, basically without using electricity or without using any instrument. And these are some self-cleaning coatings. Come later. In building and construction industry also, everywhere is nanotechnology. Different nanomaterials are used in cement, basically to reinforce concrete in a better way. Nanopigments are there, nanopaints are there to protect the building for a long time, and some waterproof paints, some self-cleaning buildings are there. Self-cleaning is basically, this is depending on different nanomaterials. It may be hydrophilic or hydrophobic. Basically we don't need to clean, but just organic or especially organic pollutants or different microorganisms, when it grow on the buildings, basically the nano paint, basically which contain titanium, zinc oxide or different nanomaterials, so it can kill them, kill the microorganisms. It can degrade the organic waste, and when water comes, so automatically it will just this kind of, it will so first step will be to decompose the organic pollutants, and then when water will come, it will take all the moist and it becomes clean. So say we don't need to clean from outside, but it will automatically clean. And these are actually, this is the building, very famous Jubilee Church in Rome, basically utilizing nanotechnology, this nano paints or nanotechnology, which utilizes nano TiO2, alumina and zinc oxide powders. Basically TiO2 and zinc oxide here helps to protect the building from UV rays, and alumina helps to make anti-scratch coating, means if we scratch also, it will not, no mark will be there. So in textile industry also, it has huge impact, in especially in winter days, if we use some socks that give some bad smell, right? But if you, but why this bad smell comes, that is due to basically some bacterial or fungal activity. So if we use some antibacterial or anti-fungal fabrics, then body odor will not be there, and also socks, we don't need to wash it every day, right? And some scratch resistant fabrics will also be there. Some wrinkle-free textiles will be, some wrinkle-free textile will be there, where we don't need to iron every day, right? So in transportation also, there is nanotechnology in our in our front windshields. So usually some wipers are there, right? But if it needs some water repelling technologies, just what hydrophobic coatings are there, then we don't need to just use wipes. Automatically in the rainy season, when water comes, it will go automatically and remains the glass clean. And we are using different CNT or alloy based lighter nanoparticles for to make the frame of the car more lighter and more tougher. And different nanosensors are being used inside the car to monitor temperature, oxygen level, pressures inside the car. And also we are using different wear resistant tires for better durability, and scratch resistant coatings, some nano paints or different coatings for increasing durability. And ceramics with improved catalyst basically help to reduce emission. In water treatment also, there are several nanotechnological approaches are there. Nano absorption, so using different nanomaterials, basically it can absorb different organic or inorganic pollutants from water. And using different membrane based separation process, we can separate different inorganic ions, different microorganisms, turbidity, very small particles. So and in last step in photocatalysis, usually in our filter also we are using different UV light. So basically that UV light helps to, and within the filters different nanomaterials, photocatalytic nanomaterials are there, so it can kill the pathogenic microorganisms or some organic pollutants. So finally, when this kind of nano filters will be used, so we can get pure water for drinking water. And there are several other applications. I just give only a few, and there are also in with the advantage, there are also certain disadvantages, like it can be harmful for our body. Also, some environmental issues are there, some military issues also are there. Suppose basically, since nanoparticles are very small, it can easily inhale by ourselves and it can deposit on our lungs. So it can give some respiratory problems, some tissue damages, and also it can reduce the ability of alveolar macrophages to clean foreign materials out. And also, since particles are very small, and so it can manipulate manipulate the gene, and also we can lose our control over ourselves. Basically, nanoparticle can control our own body. So there is of course risk. And different nanoparticles has several disadvantages, like magnetic nanoparticles. It can aggregation of nanotubes, so it will be difficult to remove the body. Also, some in quantum dot based application, so some quantum dots will using different heavy metals like cadmium also, so which will be again some toxic effect on our body. And some other nanoparticles will have create some allergy related problems also. And in military, basically one positive thing that we can save ourselves from enemy. At the same time, if we are using some advanced guns or explosive or some missiles using some nanotechnology, so that will be, if we see some bigger proportion, basically it can kill a lot of mankind, right? So basically it will go against our mankind also. So basically, in conclusion, nanotechnology or nanoparticle is everywhere. It has huge impact in our research field. It is expected to have an impact on every industry, but we need an excellent level of scientific research to manage the risk, to know about the risk of nanotechnologies. So there should be a balanced communication between risk and benefits. So with this, I want to conclude, and thank you all for your attention. Please, if you have any questions.
Thank you, sir. Thank you, Dr. Dandapat, for your nice presentation. And I think everyone has enjoyed the session, and they are also enriched with this information you have supplied in this throughout the session. Now the session is open for question answer, and I got so many questions. I'll just selectively ask 2-3 questions. First of all, SK Das. He has so many questions. I just want to give one question. He asks, is there any research work is going on to control COVID-19 through nanotechnology?
Yeah, lot of research is going on, but I think still no such. I'm not doing in this area, but lot of research is going on for kind of detection. Also, I think already some techniques are there, but still vaccination procedure nobody knows when it will come.
Okay. Then next question is from our student Ananya Banerjee. He asks, is nanoparticle is like behaving like as a classical particle or it's quantum particle? Which one is
Quantum dots, actually quantum dots will have basically some quantum phenomenon will be there.
okay? Then this nanoparticle is following this quantum mechanical rules.
Yeah, basically not bigger particles may deviate, but I guess smaller particles, especially quantum dots, are following may follow quantum mechanics.
Sir, I have one question. Is quantum dot the size is ranges from which dimension, from where to where?
Sorry,
So
please repeat, ma'am.
Quantum dot, the
Yes.
dimension will be how much? That's minimum.
I think less than 10 nanometer.
Okay. And another question from Ibrahim Mohammed. He asked very early: can nanotechnology be utilized in post-harvest management of food losses?
Yeah, it can increase. So in that slide also, I'm telling it can increase the means what he asked about harvesting, right?
Yes, post-harvesting, this food losses
Yeah,
are there. So
it
can we
increase
utilize?
it can increase the photosynthesis parts also by absorbing. Means, a lot of research are there using especially TIA2 nanoparticles to increase the photo harvesting process, basically to increase the photosynthesis and productivity also.
Another question from Arup Sarkar. He asked, is nanotechnology is applicable for social science like geography, other science, social science subject?
Social science, yes, since it is everywhere. So I think geography everywhere. So all the social means all economy also will depend on different social sciences, right? So basically, if it is in the agricultural field, also this is one kind of social things. I think social benefits will also be there. All everywhere will be nanotechnology.
Okay, sir. And so another question from SK Das. What are challenges of nanotechnology in the chemical industry? Means, which kind of challenges are facing
Yeah,
nanotechnology in
just
chemical
as I
industry?
said, basically we need, first of all, we need to know the its harmful effects in environment, also in our body, also a detailed study. Lot of studies are there. Still we need to have some detailed investigation on how it is interacting our body, or how it is interacting with the environmental things also. And in chemical industry means, yeah, disadvantages means somewhere chemical industry. What he asked about chemical industry?
Yes. What kind of challenges are facing nanotechnology are facing in chemical industry? Nano-based compounds are facing when we are going to do in large scale in the industrial scale.
Basically, one see, if it is applied in different industry also, so when it is released to the environment, you need to know about its environmental impacts also, how it will be just interacting with environment means, and also in our body also, in environment means it may be on the air, it may be in the water, so everywhere may be there. So yeah, certain disadvantages are there, like it is not very much predicted that how it is, since it is very new, and how a lot of research is going on, but since how and in which organ these nanoparticles are interacting, in how way, in which way, it is still the researches are going on. But lot of research is already done. Somewhere it is yes, some nanoparticles are creating some problems to some in our body also, in environment also, but some green nanoparticles, especially some carbon-based nanomaterials are much less toxic. So those are practically used in a lot of fields.
Sir, I have seen, we have shown that in presentation that by using that nanotechnology, people are forming glass door and different kind of glass door, then car door.
Yes,
For,
yes.
then in that kind of industry, chemical industry, what kind of what kind of difficulties are arises?
Difficulties, see, basically whatever I'm saying, if it is difficulties mean, yeah, of course it is compared to the normal. Suppose if no such coating is there, and more advantages is there, mostly the advantages is there, but difficulties means only we need to consider about its environmental effect. If it is no such, suppose if in the glass no such coatings are there, so it will be means it will be it will not clear, just clean the glass seals also. But if some coatings difficulties mean, one might be there if we are using different paints, so maybe but traditional paints will release some organic volatile compounds, but nanotechnology usually don't release those organic compounds. Usually those are, if it is inorganic nanomaterials, then it will not be so much, it will not release so much toxic organic volatile organic compounds, which may be which may be problematic for our body also. But still there might be some volatile organic compounds also, which can if also some nanoparticles are detaching from somewhere, so it can inhale in our body, so some problematic that it will be there.
Okay. Now I think this much is over. Thank you, sir. Thank you for your nice presentation and this question answer part also. I thank you once again from the Department of Chemistry on behalf of the Krishnath College. So now,
thank you all of you for arranging such a nice program also, and also I guess BSc or MSc, especially the BSc or MSc students might get some flavor, so that they can be motivated in these directions like nanotechnology or green chemistry anywhere. So I like to thank you all of the organizers and all of you for arranging such a nice program and giving me the opportunity to say something about this important topic. Thank you all.
Thank you, Dr. Dandapat.
Ashit Kumar Das want to say something. Ashit, please.
Thank you, Dr. Dandapat, for sharing your valuable time with us and share your knowledge about nanotechnology. We are really enriched about nanotechnology. Thank you once again for your for sharing your time with us.
Yeah, thank you all.
Thank you, Dr. Dandapat, for your nice presentation in the field of nanotechnology, and all we become enriched from your valuable talk and learned that how nanomaterials are important in our daily life. Thank you once again. Now we are almost at the end of our webinar. Now it's time for vote of thanks. I request Dr. Barnali Mukherjee, Coordinator IQAC, for vote of thanks. Please, Mrs. Mukherjee.
Thank
Dr.
you.
Mukherjee.
Thank you, Professor Nath. And it has been really amazing to hear such lucid and enlightening webinar. And for this, I want to thank on behalf of not only IQAC, but on behalf of Krishnath College itself. I want to thank Professor Sanjay Bhar, where he's a professor of chemistry in Jadavpur University. I'm really thankful to Dr. Anirban Dandapat. He's the assistant professor, Kumaun University, Uttarakhand. I give my heartfelt hand to our principal, Dr. Shujata Bakchi Banerjee. I am thankful to our president, Sri Mrinal Kanti Chakraborty. It is amazing for chemistry department to organize such an enlightening and interesting webinar, and I do give my thanks to Sri Biplab Bandhopadhyay, TCS, Krishnath College, and last but not the least, I want to give my thanks to the technical team that was supported by Mr. Sujan Shaha and other friends of his like Taposh Kundu, Molloy Banerjee, Ujjwal Patro for their technical support. We are really thankful, sir, that you all have given your precious time to become one of our eminent resource person in this webinar. And thank you, Chemistry Department, for organizing such an interesting webinar. Thank you, and over to you, Sanjay.
Thank you. So I end this recording now?
Yeah, if it is all, then
Okay, thank you.